Thanks for tuning in at Brackeys.
Hello everyone and welcome to this video on creating a wave spawner inside of Unity using C#. So this video is not part of any particular series because I thought I could describe the process of making a wave spawner in pretty general terms. So the script that we are going to be making today should be fairly generic and therefore very easy for you to modify to suit your project. And well, before I get started, I quickly want to show you just what we are going to be creating and how you can easily download it if you don't want to be creating it with me today. So if you simply want to use this in your own project, then you can go to Brackeys.com and you can navigate under the 2D platformer course. It's also under projects. Click on that. And I know this is in the 2D assets pack, but it will also work just fine for 3D games. You don't actually need to change any code in order to make it work for a 3D game. But anyway, just go ahead and download that, and I will make sure to put the finished product inside of the 2D assets pack once downloaded, and then scripts, and I'll make a folder here for the wave spawner. Cool. So now that that's all said and done, I quickly want to jump into Unity here and show you what it is we're going to be making. So you can see here I have currently 3 spawn points set up in my level, and you can see that I've just make sure that they have this icon so we can easily see them in our scene view. And then on the Game Master object I've been using for the game here, we have a script called Wave Spawner, and this is the central component, of course. And this has a wave class, which is then stored in an array called waves. And we can easily add more waves by simply changing the size of this to 4 to add another one. And each wave currently has a set of properties, and these are a name, the enemy prefab that we want to spawn, the number of enemies we want to spawn, and the rate that we want them to spawn in. And it's very easy for you to add more stuff to this if you want to have more kind of possibilities for each wave. So, and you can see I've just quickly made 3 waves here, and they are all using the same prefab, which is the Alien Spaceship 1. And all of this other stuff that I've set up here is part of the 2D platformer course. This entire project has been made in a series of videos, which you can, of course, check out. So check out the 2D platformer course. So we have these waves. We have a list of, or an array of spawn points, which are simply dragged in. Then we have a time between waves, which we can tweak while the game is running too. Then we have a next wave spawn time, or a countdown timer, if you will. And this shouldn't be touched. It's simply there so we can see when the next wave will spawn. And this is something you would typically put in the UI, some kind of big countdown timer when there are no more enemies left. And then we have this state. And this is simply an enum, which shows us whether or not we are currently counting down, whether we are spawning the level, or whether we're waiting for the player to kill off the enemies. Cool, and that again shouldn't be touched, it's just there for display purposes. So when I go ahead and hit play now, you can see that this goes up to 5, starts counting down, and once it reaches 0, it spawns 2 enemies, and you can see they spawned at the same point. And then it starts counting down again once I've killed them, and you can also follow what is going on behind the scenes down here. And you can see that the system keeps going even though I get respawned and all that. So you can see wave completed, it counts down again, and here comes the final wave. And this is a tough one. I'll see if I can do this. I could. And you can see it says wave completed, no more waves, and it starts looping. So it will simply spawn the next or the first wave and simply keep going that way. And one thing you could do here is simply have a game completed screen if you want to make all the waves yourself. Or you could also have kind of a stat multiplier that would make the waves harder each time it looped through. So that's all something you can add on to the system, but this should provide a nice base. Cool. So let's actually take a look at creating this script. So let's remove the component here, and whoops, it looks like I have some malware. It's currently being deleted. It's a weird thing Windows 10 is doing. And I'll quickly remove the wave spawner script here. And also we'll remove the spawn points that I've created. And so we should be starting from scratch here. So right now when we hit play, there is nothing on the GM object and nothing is going on in the console. And we actually have nothing set up. Cool. So to start this off, let's go ahead and create a wave spawner script and go under new script and select C#, hit create and add, and let's double click this to open it up. And I'm actually not using Mono Develop here. Instead, I'm using Visual Studio. And I also have a video on setting that up if you wish to use the same. Mono Develop should do just fine. The namespaces we're going to be using here are Unity Engine and System.Collections because we are going to be using enumerators. And well, we can go ahead and kill off these methods for now, but we are going to be adding them again in a second. But first off, I simply want to focus on the very first part of creating this wave spawner, which is defining what a wave in our game should be. So in order to do that we need to create a custom class, and I'll just put this inside the wave spawner. You could also put it outside. That's actually completely up to you. And I'm simply going to call this wave. And then we are going to open up some curly brackets, and inside of this we're going to have a couple of variables. The first one is going to be the name of the wave. This is cool to have if you want to announce what wave is currently coming. As you saw, I did that. I didn't display it in the UI yet, but I had it displaying in the console. Then we want a reference to the prefab that we want to instantiate at our spawn point, so that the actual enemy game object itself. And for that, we could simply do a transform reference. And we'll simply call this enemy. Then we want a public, and this is going to be an integer, and that's going to store the count simply and the amount. We could also call it, I'm simply going to call it count here. And actually, no, let's do count. I like it better. And then finally, we'll have a public float, which is going to be our rate, our spawn rate. And we could also do a delay here, but I find it a bit more logical to have a spawn rate and then simply do 1 divided by the rate. It's basically the same thing. Okay, so one thing that we will have to make sure that we do with this class. I mean, you can put all the stuff in here that you want to. The stuff that we are definitely going to be needing in this tutorial is enemy count and rate. Other than that, you can configure this just the way you want to. But one thing we will have to do is mark this as serializable. So we are going to say system.serializable up here in square brackets. And what this does is simply allows us, well, basically what it means for us at least is it allows us to change the values of this of instances of this class inside of the Unity inspector. So when we now go on to making a public wave array and call this waves, then while we are including when including this tag up here, we are actually going to be able to edit it inside of Unity. So you can see here that we now have this waves array, and we can start adding waves, and we have all of these properties to edit. If we went ahead and deleted this, well, you can see that that list or array simply disappears. So we need this in order to edit it inside of Unity. Cool. So that's all fine and dandy. Next up, we are going to create a private integer, and this is going to store the index of the wave that we want to be creating next. So this is simply going to be called next wave, and it's going to be is simply going to default to 0. Cool. Then we want to have a public float that stores our spawn, our time between waves. And we're going to default that to 5 seconds. And yeah, all of these time measurements are in seconds. And next up, we want to have a private. Actually, let's just make this public so we can see it in the inspector, just to see if everything is working. But we will mark this at private once we're done. And this is going to be the wave countdown. And that's simply going to default to 0, or you could just close it off, which I'm going to do. Cool. So now in the start method, void start. Wow. Cool. Whoops. All right. My microphone sometimes gets in the way, which makes it kind of hard to type. Cool. So inside of our start method, we want to set the wave countdown equal to the time between waves. So that's going to start off at 5 seconds. Then we are also going to have an enumerator, or an enum, I should say, that stores the current state of our spawner, but we'll make that in a second. First off, I want to declare an update method. Jesus Christ. Okay, an update method, and inside of this, we are simply going to write that if wave countdown is less than or equal to 0, so if it's time to start spawning waves, then we want to check if we've already started spawning waves. So this is where we kind of need that state. So because we could do a method here called spawn wave, and give it the wave that we wanted to spawn. But then we would be starting to spawn a wave every time the computer drew a frame. So we have to make sure that we only start spawning a wave one time. And in order to do this, let's declare an enum up here, and that's going to be a public enum, and we are going to call this spawn state. And it's going to store the values spawning, waiting, and counting. And these do not need to be capitalized. Then down here we can check that if state, we also need to store this in a variable, of course. So up here we're simply defining the data structure. Now we also need to actually make that a variable. So we'll make a public spawn state called state and default it to spawn state dot counting. Awesome. And I'll change that to private. I don't think we need to be viewing that in the inspector. So if it's time to start spawning a wave, and if state is equal to and if state is not equal to spawn state dot spawning, well, then we want to start spawning a wave. So here we want to start spawning wave. Then if we haven't reached 0 yet, then we simply want to say that wave countdown minus equals time dot delta time. So this will simply make sure that we go down the appropriate amount of time for each frame. And this will make sure that our actual countdown timer will be kind of relevant to time and not to the amount of frames that we draw per second. Cool. So now we could actually go ahead and set up the method for spawning a wave. So this is going to be using an I enumerator. And the reason for this is that we want to be able to wait a certain amount of seconds inside of the method. And in order to do this, instead of writing void, we write I enumerator. And I'm not going to go into exactly what I enumerators actually do and kind of how they work behind the scenes. I'm simply going to say that this is the method, this is the way of creating methods that will be able to wait a certain amount of seconds before continuing. And in order to use this, you have to also include system.collections. So we're going to make an IEnumerator method, and we are going to call it spawn wave. And it's going to take in as an argument a wave, which we're going to call underscore wave. And IEnumerators basically need to return a value. So down here, we'll simply do yield break, and that will return a nothing. And that will make sure that we don't get this error that popped up here. You can see that not all code paths return a value. We'll simply make sure to end your method with yield break, and that should go away. Cool. So basically, what do we want to be doing here? Well, first off, we want to set our state equal to spawn state.spawning. So now we are actually spawning. And when we are done spawning, then we want to spawn a bunch of things. And once we are done spawning, we want to set state equal to spawn state.waiting, because now we are waiting for our player to kill off all of the enemies. Then here we want to do a spawning logic, but let's first make sure to call this. So up here we want to start spawning a wave. Well, instead of just doing spawn wave and then putting in the wave that we are currently going to spawn, because this is an IEnumerator, we simply need to say start coroutine. And then in here we call the method. So in here we say spawn wave, and we give it the wave that we want to spawn, which is currently waves with an index of next wave. Like that, okay? So instead of simply calling this and using a semicolon, because this is an IEnumerator, we need to call the start coroutine method, and that is going to do all of that for us. Awesome. So now in here, what we are able to do is we are able to loop through we are able to create a for loop that will run the number of enemies that we want to spawn. So it will make sure to loop through count number of times, and count is of course equal to the number of enemies that we want to spawn. So for and I equals 0, I is less than wave.count, then we want to increment I. And in here we can then say that we want to spawn an enemy. So we are going to create a method for that also. And we could all do all of this inside of this method, but I think it's much easier to read if we have methods for spawning waves, for spawning enemies, and for searching, checking if enemies are still alive, and doing all of that in separate methods just makes the code much easier to read. So here we're going to have a spawn enemy, and that's going to take in as an argument an enemy of some sorts. I actually have an enemy class, but we declared ours as a transform, and we're going to call it underscore enemy. And in here we want to spawn enemy, and for now we are simply going to debug.log spawning enemy, and we're going to print out the name of that enemy. So that's going to be fine for now. Later we'll add the spawn points and make sure that they are actually instantiating. So in here we'll simply call this spawn enemy method, and the enemy that we want to be spawning is wave.enemy. And then we want to wait a certain number of seconds. So right now, if I just go through this, we'll begin at the start method. It's going to set our wave countdown equal to the time between waves, which is defaulting to 5 seconds. Then it's going to go down here, and it's going to say, well, we are not at 0 yet, so it's simply going to subtract the number of times or the amount of time that has passed since the last time we drew a frame, meaning that it will simply subtract one measurement each second from this wave countdown. So it's simply going to count down from 5. And if it hits 0, then we want to check if we are already spawning. And the first time we are of course not going to be spawning, so therefore it's going to start spawning, which takes us down here, and it's going to say, well, now we are actually spawning. Then it's going to loop through the amount of enemies that we want to spawn. And for each enemy that we want to spawn, we are going to call the spawn enemy method, which takes us down here. And it's going to instantiate an enemy, which we haven't done yet. For now, it's simply going to write down in the console that we are spawning an enemy. And then we go up here, and then we want to wait a certain amount of seconds before looping through again. So before continuing to the next iteration of the loop, we want to put in a wait 4 seconds. And this is why we put our enumerator here, because this allows us to do this: yield, return new, wait 4 seconds. And in here, we can simply put 1 divided by wave.rate. So I know this looks very weird, and I know this does too. Simply ignore it. Simply know that whenever using an enumerator, we should end with yield break. And whenever we want to wait a certain amount of seconds, we put in yield, return new, wait 4 seconds, and then the amount of seconds that we want to wait. And in this case, that's going to be equal to 1 divided by our rate. Or if we had put in a delay, we would simply put in wave.delay. But that's completely up to you. So it's going to wait this a certain amount of time and then spawn another enemy and then wait again and spawn another enemy until we've reached the point where we have as many enemies alive as we wanted to spawn. And then it's going to set our state equal to spawn state.waiting.